Okay, so each of these functions, just like you did with your box that you maximize, you're going to graph, and they're going to have anything with a max and min. So if you remember from last chapter, anything that's a turning point going like this would be a max, and any kind of turning point you have going like this would be a min. Some graphs are going to have both a min and a max. Some graphs will only have one. Some graphs might have two maxes and one min, and so on, right? You just have to look at the graph and see all your turning points. Okay, so let's look here and do this one. So x cubed plus 4x squared minus 5x, and then graph. Okay. I can see the min, but I can't see the max. That means I have to make my y higher. So I go to my window, and I'm going to make my y max 30. So my x's are going from -10 to 10. My y's are going from -10 to 30. And then when I graph, I can see both the max and the min. Okay. So what we're going to do is label both. What is the max point? What is the min point? So calculate that by second trace and go down to maximum. And it says left bound. That means I want to go to the left side, right, just somewhere, left side of that max, push enter. Right bound, so you want to go to the right side of that max, push enter. And then guess, yes, so you push enter one more time, and it calculates that maximum for me, -3.19, 24.19. Right, that's my max point on that graph. And then you do the exact same thing now, but with a minimum. So you go second trace. Now I'm going to go number 3, minimum. And now I need left bound. So I need to go all the way down the left side of the minimum, push enter. Go to the right side of that minimum, push enter. Guess, yes, push enter one more time. And that's the min, 0.52, -1.38. I found the max and the min. Should we do no one? Let's try the one below it. So again, I go to my y equals and sub that in, put that into my y equals. -4x cubed plus 12x squared plus 4x minus 12. Oops, I have double negative, don't I? And then graph. Okay. And I can see my max, but my min is kind of getting covered. So I want to make my y min, right, my window to go down. So I'm going to go back to my window, maybe change my y max to 25, but my y min, it needs to go lower. So let's do -20. And now I can see both the min and the max.
What did you do when you did the window?
I changed y min to -20 and y max to 25. I kept x's the same, -10, 10. So I need this min and that max. This one has one of each again. So let's calculate the min and the max. So second trace, minimum. Left bound, I gotta go to the left side of the min. Right bound, I have to go to the right side of the min. Guess, yes, enter again. And I get this, -0.15, -12.32. And then I need the max up here, the max. So second trace again. Now go to number 4, the max. Left bound. So I want it just to the left of the max, somewhere around there. So enter. I need the right side of the max. Enter. Guess, yes, enter one more time. And I get 2.15, 12.32. is going backwards. So let's start with something we know. We have done factoring of a quadratic, right? So if I give you a quadratic, something like, let's do something easy. And I said, factor this. So together we would think, okay, what do I multiply equals 2 but add equals 3? 2 and 1. So I'd factor, and then we would solve it, right? What plus 2 gives me 0? What plus 1 gives me 0? Okay? So here's my polynomial. I factored and got the roots. So going backwards means if I give you the roots, let's do something easy again, like 1 and -1, right? Could you then give me the factors to multiply to then get the polynomial? Right, if positive 1 is a root, then I must have had x minus 1 as a factor. And if negative 1 was a root, then x plus 1 would have been a factor, right? Because I would have thought, what plus 1 gives me 0? Negative 1. And then I can multiply that and get the polynomial. So we're doing that only with more than just 2 roots. We're doing cubic or quartic functions. Let's get some more, I need some more space here. There we go. Okay, so I have the roots 5, 6, and 7. So if 5 is a root, what would have been a factor? X minus 5, right, because what minus 5 gives me 0. If 6 was a root, what would have been a factor? And 7, right? I'd have x minus 7. Now, I need to multiply all 3 of those together. So just work left to right. So I'm going to multiply the first 2 together. That would be a FOIL. So x times x is x squared. X times -6, negative 6x. Negative 5 times x is negative 5x. Negative 5 times -6 would be positive 30. I do have some like terms to combine. So I end up with x squared minus 11x plus 30. But that's only multiplying 2 together. I still have 1 more to multiply. Whenever I have more than a FOIL, I like to set it up in a table. I found that students make the least amount of errors and your work's more organized if you use a table. And what I mean by a table is you let one of the polynomials be your columns, and you let the other polynomial be your rows.
I do not have enough room.
And then you just multiply the corresponding row with column to get all your terms. So I'm still taking x squared times each term, negative 11x times each term, 30 times each term. But instead of getting this huge, long, horizontal row of 9 terms, or 6 terms, I mean, I can use a table and have them all together. So what I do then is I multiply. X times x squared is x cubed. X times negative 11x is a negative 11x squared. 30 times x is 30x. Negative 7 times x squared. Negative 7 times negative 11 is positive. And negative 7 times 30 is negative 210. So the other cool thing that happens in a table when you're multiplying is your like terms end up diagonally of each other. So you don't have to go through the line and find them. They're just right there. So my answer then, right, the cubic function with these roots would be, start with the standard form, so start with the highest power, x cubed. And then I combine my squareds, negative 18x squared. Combine my x's, so that would be 107x. And then my constant minus 210. There's my answer. How do I check myself? If I were to graph that, okay, so again I have 3 roots, negative 5, negative 5, negative 5. So
You just
x
add the five,
plus
don't
5, x plus 5, x minus 1 would have been my factors for those three roots. Multiply the first two together, and we can do that by foiling, first outer inner last. So x times x is x squared, x times 5 is 5x, 5 times x, 5x, 5 times 5 is 25. Combine like terms, I have two x terms, x squared plus 10x plus 25. But I'm not done because I still need to multiply this x minus 1. So to multiply a trinomial with a binomial, set up a table. These three terms will be my three columns. These two terms would be my rows. And then I just multiply the corresponding column with its row. So x times x squared is x cubed. X times 10x is 10x squared. X times 25, and then negative 1 with everything. So negative x squared, negative 10x, negative 25. So then to write the answer, I need to combine like terms. And I can see that I have two x squared terms here. I have two x terms there. So x cubed, negative 1 plus 10 is 9. 25 plus a negative 10 would be 15. And then minus 25. That's my answer. Right. So again, to check myself, if I was going to graph that, if I put this into my y equals, I should see it negative 5. In the last example here, negative 2, so x plus 2, 0, so you'd have x plus 0, which is just x, and then 1, so x minus 1. So again, I'm going to multiply these first two together, x squared plus 2x, right? But I still have this one, x minus 1, right? So this time, instead of a table, I can actually just finish off with a FOIL. X squared times x is x cubed. X squared times negative 1 is negative x squared. 2x times x is 2x squared. 2x times negative 1 is negative 2x. And then I have like terms. So x cubed plus x squared minus 2x. So if I were to graph this cubic function, and my roots are 0, 1, and negative 2, right? I could graph it and see that it goes through those 3 points. It'd probably look something like this, right? That's one way you can check yourself.